I am Zenvets Medina, your reporter for today, and we are already in our chapter 5 of our module in our lecture, which talks about reliability. So, my co-reporters with me are Rodrigo Zarla Mabu and Zartiga Chanel May. So, our topic outline for today is the concept of reliability, sources of error variance, reliability estimates, and the Kuder-Richardson formulas. So our intended learning outcomes is first to determine the importance of concept of reliability. Second would be identify the sources of error variance, have knowledge about the reliability estimates, and understand the Kuder-Richardson formulas. So what is reliability? So reliability is the degree of correlation between various forms of a test, or between halves, or between two administrations of it. It can also be characterized operationally as reliability. However, a more essential definition involves the objectives to be met. To further discuss, let us know the concept of reliability. It is the consistency and repeatability of data generated by a method, methodology, or experiment. If a method of evaluation consistently generates steady and similar outcomes under consistent settings, it is said to be trustworthy. If the attribute being assessed is stable and does not change abruptly, consistency is ensured in part. However, factors such as examinees' physical and mental status, insufficient concentration, distractedness, and responsiveness to visual and sensory stimuli in the environment, among others, might cause inaccuracies. When determining the reliability of a measure, the examiner must be able to distinguish between the errors caused by inefficient measurement and the true variability of the true score. In the absence of errors, a true score is a subset of measured data that would repeat consistently throughout multiple instances of testing. As a result, the overall score generated by a test is a mix of genuine score and measurement mistakes. In statistics and psychometrics, dependability refers to a measure's general consistency. When a measure generates consistent result under the same conditions, it is considered to have high reliability. High dependable scores are exact, repeatable, and consistent from one assessment session to the next. Sources of error variance. First, test construction. Item sampling or content sampling, words that relate to variation among items within a test as well as variation among items between tests, is one sure of variance during test creation. Consider administering two or more exams to assess a certain skill, personality trait, or body of information. There will undoubtedly be differences in the wording of the items as well as the material sampled. A problem in test development, from the standpoint of a test developer, is to maximize the proportion of total variance that is true variation while minimizing the proportion of total variance that is mistake variance. Test administration. During the delivery of the test, sources of error variation may have an impact on the test taker's attention or motivation. One type of error variance is caused by the test taker's reaction to various stimuli. Unwanted influences during the administration of a test include, for example, aspects relating to the test setting, such as room, temperature, lighting, ventilation, and noise levels. The tool used to enter responses, as well as the writing surface on which responses are recorded, are both environmental variables. Test takers' factors are another potential source of error variance during test administration. Error variance can be caused by a variety of factors, including pressing emotional issues, physical discomfort, lack of sleep, and drug or pharmaceutical side effects. A test taker may make a mistake when entering a test response for any number of reasons. Other potential sources of test-taker-related error variance include formal learning experiences, casual life experiences, therapy, illness, and changes in mood or mental state. Variables relating to the examiner could be a source of error variance. Physical look and behavior of the examiner, as well as the presence or absence of an examiner, are all aspects to consider. In some testing scenarios, examiners may consciously or unknowingly deviate from the protocol established for a specific examination. Some examiners may unintentionally reveal information during an oral examination by accentuating crucial terms when posing questions. Head nodding, eye movements, and other nonverbal gestures may be used to convey information about the correctness of a response. The level of professionalism displayed by examiners is clearly a source of error variance. Test scoring and interpretation. Many exams have practically reduced error variance caused by scorer variability thanks to the introduction of computer scoring and the rising dependence on objective, computer scorable elements. Not all tests, however, may be graded using grids darkened with number 2 pencils. Individually given IQ tests, some personality tests, creativity tests, a variety of behavioral measures, and a slew of other tests still necessitate hand grading by experienced individuals. Individual intelligence test manuals are usually quite precise regarding scoring standards so that examinees' estimated intelligence does not fluctuate depending on who is assessing and rating them. Error variation can be caused by scorers and scoring systems. A test may include objective type elements that can be scored by a computer and have a high level of dependability. Even so, there's a chance that technical malfunction will contaminate the data. When scoring involves subjectivity, the scorer or rater can be a source of error variance. In the administration of certain non-objective personality tests, tests are of creativity, and certain academic assessment, the element of subjective in scoring may be substantially greater, such as examinations. Even behavioral assessment might be subject to subjective scoring. Other sources of error. Certain types of assessment scenarios encourage specific types of systematic and non-systematic mistake. Consider determining how much agreement there is between partners on the type and quantity of physical and psychological abuse in the relationship. According to Moffitt et al. In 1997, they said that because partner abuse usually occurs in private, there are only two persons who really know what goes on behind closed doors, the two members of the marriage. Forgetting, failing to observe abusive behavior, and misinterpreting reporting instructions are all potential sources of non-systematic error in such an evaluation circumstance. Let's now go in the reliability estimates. So we have first test, retest, reliability estimates. Test, retest reliability is an estimate of reliability obtained by correlating pairs of scores from the same people on two different administration of the same test. The test-retest measure is appropriate when evaluating the reliability of a test that purports to measure something that is relatively stable over time, such as personality trait. If the characteristic being measured is assumed to fluctuate over time, then there would be little sense in assessing the reliability of the test using the test-retest method. When the interval between testing is greater than 6 months, the estimate of test-retest reliability is often referred to as the coefficient of stability. An estimate of test-retest reliability may be most appropriate in gauging the reliability of tests that employ outcome measure such as reaction time of perceptual judgments. However, even in measuring variables such as these, and even when the time period between the two administration of the test is relatively small, various factors such as experience, practice, memory, fatigue, and motivation may intervene and confound an obtained measure of reliability. Parallel forms and alternate forms reliability estimates. The degree of the relationship between various forms of a test can be evaluated by means of an alternate forms or parallel forms coefficient of reliability, which is often termed the coefficient of equivalence. Although frequently used interchangeably, there is a difference between the terms alternate forms and parallel forms. Parallel forms of a test exist when, for each form of the test, the means and the variances of observed test scores are equal. In theory, the means of scores obtained on parallel forms correlate equally with the true score. More practically, scores obtained on parallel tests correlate equally with other measures. Alternate forms, on the other hand, are simply different versions of a test that have been constructed so as to be parallel. Alternate forms of a test are typically designed to be equivalent with respect to variables such as content and level of difficulty. Obtaining estimates of alternate forms reliability and parallel forms reliability is similar in two ways to obtaining an estimate of test-retest reliability. First, two test administration with the same group are required, and second, test scores may be affected by factors such as motivation, fatigue, or intervening events such as practice, learning, or therapy. An estimate of the reliability of a test can be obtained without developing an alternate form of the test and without having to administer the test twice to the same people. Deriving this type of estimate entails an evaluation of the internal consistency of the test items. Logically enough, it is referred to as an internal consistency estimates of reliability or as an estimate of inter-item consistency. There are different methods of obtaining internal consistency estimates of reliability. One such method is the split-half estimate. Split-half reliability estimates is an estimate of split-half reliability that is obtained by correlating two pairs of scores obtained from equivalent halves of a single test administered once. It is a useful measure of reliability when it is impractical or undesirable to assess reliability with two tests or to administer a test twice. The computation of a coefficient of split-half reliability generally entails three steps. Step 1 is to divide the test into equivalent halves. Step 2 is to calculate a PR/R between scores on the two halves of the test, and finally adjust the half-test reliability using the Spearman-Brown formula. The Spearman-Brown formula allows a test developer or user to estimate internal consistency reliability from a correlation of two halves of a test. It is a specific application of a more general formula to estimate the reliability of a test that is lengthened or shortened by any number of items, because the reliability of a test is affected by its length. A formula is necessary for estimating the reliability of a test that has been shortened or lengthened. Flashed on your screen is the general formula of the Spear-Brown, where R sub SB is equal to the reliability adjusted by the Spearman-Brown formula. Rxy is equal to the PR/R in the original length test, and N is equal to the number of items in the revised version divided by the number of items in the original version. A Spearman-Brown formula could also be used to determine the number of items needed to attain a desired level of reliability. Other methods of estimating internal consistency. Inter-item consistency refers to the degree of correlation among all the items on a scale. A measure of inter-item consistency is calculated from a single administration of a single form of a test. An index of inter-item consistency, in turn, is useful in assessing the homogeneity of the test. Tests are said to be homogeneous if they contain items that measure a single trait. As an adjective used to describe test items, homogeneity is derived from the Greek word homos, meaning same, and genus, meaning kind. Homogeneity is the degree to which a test measures a single factor. In other words, homogeneity is the extent to which items in a scale are unifactorial. In contrast to test homogeneity, heterogeneity describes the degree to which a test measures different factors. A heterogeneous test is composed of items that measure more than one trait. Finally, the Kuder-Richardson formula. Dissatisfaction with existing split-half methods of estimating reliability compelled Frederick Kuder and Richardson to develop their own measures for estimating reliability. The most widely known of the many formulas they collaborated on is their Kuder-Richardson formula, or KR20, so named because it was the 20th formula developed in a series, where test items are highly homogeneous, and KR20 and split-half reliability estimates will be similar. However, KR20 is the statistic of choice for determining the inter-item consistency of dichotomous items, primarily those items that can be scored right or wrong. Flashed on your screen is the Kuder-Richardson 20 formula, where RKR20 stands for the Kuder-Richardson Formula 20 reliability coefficient, K is the number of the test items, 2 is the variance of total test scores, P is the proportion of test takers who pass the item, Q is the proportion of people who fail the item, and PQ is the sum of the PQ products over all items. Coefficient alpha. It is developed by Cronbach in 1951 and subsequently elaborated on by others. Coefficient alpha may be thought of as the mean of all possible split-half correlations corrected by Spearman-Brown formula. In contrast to KR20, which is appropriately used only on tests with dichotomous items, coefficient alpha is appropriate for use on tests containing non-dichotomous items. Here is the formula of coefficient alpha, where R, A is coefficient alpha, K is the number of items, I, 2 is the variance of one item, is the sum of variances of each item, and 2 is the variance of the total test scores. Coefficient alpha is the preferred statistic for obtaining an estimate of internal consistency, reliability, and a variation of formula has been developed for use in obtaining an estimate of test retest reliability. So that is all for today. Thank you for listening and have a good day.